So here we are, 2.5 years into a global pandemic of gigantic proportions, the third coronavirus pandemic in 20 years. Focusing on COVID-2 and COVID-19 has allowed us to explore coronaviruses as a family. Two genera, the alpha and beta coronaviruses, are especially revealing, as numerous examples of coronavirus diseases in cats, dogs, cows, and pigs have been known for decades. Veterinary vaccines have proven effective in preventing severe disease, although they do not necessarily provide protection against infection, transmission, and recurrent disease. Despite the fact that coronavirus RNA polymerase has unique proofreading activity, we have witnessed the emergence of ever more transmissible variants of COVID-2. Huge advancements in diagnostics, and especially in vaccination, have helped curb the COVID-19 pandemic, although we certainly are still not out of the woods. The following are 10 key points to consider. Coronaviruses have huge RNA genomes, some 30,000 bases coding for over 25 proteins. Their genomes are ribosome ready. The first 2/3 of the positive strand RNA code for 2 large polyproteins, 16 proteins strung together, one after the other, and cleaved apart by viral proteases. The 3' end corresponds to subgenomic RNAs that code for the structural proteins, spike, membrane, envelope, and nucleocapsid proteins. 7 human coronaviruses have been identified, 4 of which cause mild common cold-like disease. Over the last 20 years, 3 pandemics have emerged: SARS-CoV-1 in 2003, MERS in 2012, and COVID-2 in 2019. Compared to SARS-CoV-1 and MERS, COVID-2 is extraordinarily contagious and consequently has led to massive infections worldwide. Fortunately, the fatality rate of COVID-2 is much less than SARS and MERS. Although proofreading activity is associated with coronavirus RNA polymerase, transmissibility continuously increases, and so we have seen the serial emergence of variants of concern that are ever more adapted to more efficiently infect humans. How to control the spread of the virus has been a major challenge. Pandemic management through behavioral measures, such as donning masks and social distancing, has proven effective. Lockdowns and quarantines have had serious impact on all our lives. Monitoring the pandemic and contact tracing have been possible through extensive use of diagnostics. 3 diagnostic platforms complement each other to provide a picture of the dynamics of the pandemic. And finally, the implementation of a novel vaccine modality, messenger RNA vaccines, have been deployed within 1 year. Clearly, this is remarkable due to the perfect timing where 3 technologies have matured and come together to bring about a genuine vaccine revolution. Here are some concept maps to better understand the interrelationships between the terms we have learned. Coronaviruses contain single-stranded RNA, positive sense RNA, about 30,000 bases long. The first 2/3 of the genome code for the non-structural proteins, 2 large polyproteins, 2 of which are proteases, and once they cleave the polyproteins, the ribosome-dependent RNA polymerase can assemble. The RD-RP uses the XON component and exonuclease for proofreading activity. The remaining last third of the genome codes for the structural proteins. To be precise, it serves as a template for short subgenomic messenger RNA segments, which are then translated to produce the structural proteins, spike, membrane, and envelope that assemble with the membrane, and in addition, nucleoproteins which associate with the genome. Altogether, they package to form new viral particles. Phylogenetic analysis of the viral genomes allows us to divide the coronaviruses into 4 genera: alpha coronaviruses, beta coronaviruses, gamma coronaviruses, and delta coronaviruses. Alpha and beta coronaviruses infect mammals, whereas gamma and delta coronaviruses infect birds. The alpha coronaviruses infect cats, dogs, and pigs, causing gastrointestinal disease and respiratory diseases. The beta coronaviruses can infect cows, also causing serious coronavirus disease. Curiously, all of these animals have existing vaccines, and the vaccines prevent severe disease, however, are less effective in preventing the infection and reinfection of the vaccinated animals. And of course, in the end, we also have discovered viruses that infect humans. Humans can be infected by both alpha and beta coronaviruses. Now let's look at human coronaviruses. Obviously, they can be divided into alpha and beta. But in this case, let's look at those that cause the common cold, as opposed to the pandemic coronaviruses we've been talking about. The first 2 human coronaviruses discovered back in the 60s were 229E and OC43, and then in 2003, SARS coronavirus emerged in China, the first pandemic coronavirus. In view of the pandemic, research was conducted to seek and try to identify new unknown coronaviruses, and immediately NL63 and HKU1 were identified, both causing common cold-like disease. In 2012, MERS coronavirus, a new pandemic, was discovered in the Saudi Peninsula. And we had thought, hopefully, that this might be the end of coronavirus pandemics. However, in 2019, we witnessed the emergence of SARS-CoV-2 and COVID-19.